My Ontario Energy Plan. So the driving question is, how might Ontario meet its energy requirements for the year 2030 in a way that is both economically feasible and environmentally sustainable? Well, for starters, Ontario's energy use is divided up into many parts. The first being 50% for nuclear energy. This is the backbone of Ontario's supply, offering consistent baseload power. That is 25% hydroelectricity, 13% natural gas, 8% wind power, and 1% solar and bioenergy. For my 70% adjustment, I have allocated to have 30% hydroelectricity, making this the cornerstone of the plan. Then 25% solar power, since we are advancing in solar technology. 10% wind power for the rural and coastal areas that have lots of potential wind energy, and 5% geothermal. As this is not yet widely used, they provide a consistent and reliable energy source. Now, for hydroelectricity, how does it work? It first starts at the reservoir and then goes down to the intake. This intake then goes through the penstock, where kinetic energy is then made from the gravity. Then it goes through the turbine, making kinetic to mechanical energy, up the generator through the powerhouse, from making mechanical energy to electrical energy. And then it goes through the power lines and it gets reached to, for example, your home, your school, or other industries. Some benefits shown that it's very efficient, it has low operational costs, and is very reliable as a power output. However, its risks is that it can be very damaging to ecosystems, especially the aquatic ones. For example, you can harm a fish's home. It can have very high construction costs for the new facilities, and the seasonal water flow can vary and also affect the energy production, making it unpredictable for everyday use. Next is house solar panels, and this will be the next thing for renewable energy. It first starts in the sunlight and then gets put onto the panel. This is when electrons are created through the layers and then gets put through the inverter, then going straight to your, for example, light bulb, making you have light in your house, creating electricity. Now, some benefits and risks. It can have abundant and inexhaustible resource, the decreasing cost for installation and maintenance, and it can be scalable and installed in any area, for example, urban, rural, or remote locations. The risks, however, is that its production is intermittent, and so it relies on sunlight, and efficiency drops during the winter months, and large installations may require significant land use. So when you think about large installations, you want to think about putting them into more rural or remote locations. Next is wind turbines. First, wind gets put through these turbines. The larger the wind forces, the faster the turn. Once they start turning, they get put into the shaft. This is the central shaft, so when the shaft spins, it also spins inside the turbine. And then it gets connected to the generator over here. And then after it goes down the tower, where the generated electricity flows and then gets put into your homes. Now, some benefits and risks. It is very cost effective, it is emission free during operation, and it's large in rural and coastal areas. So, lots of area in Ontario where we can implement these wind powers. However, the risks is that it also has intermittent production depending on the wind conditions. So, at least lots of more unpredictable energy use. And it can also require extended transmission infrastructure in the remote areas since they're so far away from more urbanized areas where the population is larger. Next is wind energy. It first starts through the cracks where the steam in the water gets put up, and then it goes through the heat exchanger over here. Then this energy gets turned into electricity through the turbine and generator, then gets put into power into your industries. With this excess water, it goes back into the land, and it gets restored, and this creates the cycle of geothermal energy. Now, some risks and benefits. It provides consistent and reliable baseload power. It has minimal land use, which is perfect for more like urbanized areas, and a small environmental footprint compared to the other energy resources. However, it has high initial exploration, high drilling costs, and suitable for locations that are limited to areas with significant geothermal activity. So this is a more high cost idea. So you can see that geothermal has 12 to 20% efficiency. Solar panels or solar power has 15 to 20 and a max of 23%. Hydro being the most, having 90% efficiency, and wind having 45 to 55 and 50 to 55 for offshore winds. Some infrastructure updates is the energy storage solutions. So large-scale battery systems can store this excess energy generated, for example, by wind or solar power, to ensure availability during the periods of low production or when energy can be unpredictable. And then the next is its transmission expansion. So upgraded and extended transmission lines to connect to the remote renewable energy projects to the urban demand centers. For example, wind or solar energy to connect it to the big cities such as Toronto. Next is the cost implications, with wind being at 1 million per megawatt with its upkeep cost at 8 cents per kilowatt, geothermal being 3.5 million per megawatt with its upkeep cost at just 5 cents per kilowatt, and then hydroelectricity being at 3.5 per megawatt and the lowest 1 cent per kilowatt, and then solar power being 2.5 million per megawatt at 3 cents per kilowatt.